Welcome to Queens College Physics Department's Distance Lab Series. This is Lab 6, Kirchhoffs Rules. Hopefully you've got some knowledge about Kirchhoffs Rules by now. And we're going to look at a circuit that's slightly more complex than you did previously and see if you can analyze it. In the resources, there is a link to the circuit construction kit, which we used before, and a list of resistance values and power supply values. You're going to use those in your circuit when you get to build it finally. And there's also a link to this video. The report, the abstract just discuss, well, hopefully you know that Kirchhoffs rules are just expressions of some fundamental conservation laws. And you should discuss before looking anything up. You should discuss what you think you understand it now. Again, this is to get your intuition down so you can compare to it later. The equipment, we covered this last time we used the simulation. However, you should remind us why we're putting in a small amount of wire resistivity and why that makes your results more real. For the data, when you build your circuit, you'll take a screenshot. There's only one circuit this time. It's a fairly simple lab. You're going to make a table in Excel, which I'm going to demonstrate for you. The analysis will consist of you analyzing the circuit, labeling and listing the different loops and junctions and writing equations, and then making measurements and comparisons. The conclusions are covered in the conclusions section. The introduction is very simple stuff. You can read about Kirchhoffs laws anywhere. They're fairly important stuff. They are simply stated as the loop laws. The sum of the voltages around any loop is 0. And the sum of the currents passing into any junction is 0. And then we get to the procedure. You'll read the procedure. You'll have to be careful. The trickiest part is to understand exactly what I want here. But it's not that difficult. This is the circuit you'll be using. This is the circuit you'll be building in the circuit simulation, which we're going to go to now. It tells you how to do the analysis, what has to be included, etc. And the conclusions ask a few questions. So let's go to the circuit construction kit using this link. This is not exactly the same one. You have to click on lab here. And here I'm going to do this, and I'm going to set conventional current, but I'm going to turn it off, and I want to see the values. And I'm going to go to wire resistivity, and I'm going to bump it up just a tiny bit. But that's too much. There, just a tiny bit. And we're ready to go. So you've already have some experience in this. One thing you should remember is that the positive direction on a battery or power supply is going to be on the side of the long line. You need this for building your circuit. You can change the voltage by simply clicking on the device. Same with a resistor. If I click here, I can change the quantity, and you have to set it to the ones in the lab write-up. So there is an extra meter here, but this does not do anything different. I'm not even sure what value it has. And the important part here is that you're measuring the currents in the different branches of that circuit. I suggest you actually put in a meter in each branch to help you keep it separate and to give you all the values. So that would look, I guess, like this. You're going to have to do a neater job than I have. Remember, you have to take a a screenshot. There, that's one loop in the circuit. Again, I mentioned this last week, I'm going to mention it again now. The way to build this circuit, or any circuit, is to do it in terms of loops. I've picked the right hand loop and I connected everything together. This is going to give me the same current here because that's an error. So if I disconnect this, and now I put in another wire here, that's still the same thing. However, now I have a place to put an extra wire and an extra meter and an extra resistor, and I can now connect them up. And now I don't have the same. And I have it in terms of 2 loops. Always the easiest way to build a circuit. When you're doing a screenshot, there's actually a facility for it here. Screenshot. If you want to start over, you can do this. You can do, if you prefer, this, but it's not very useful and it's a little busy, and since our circuit diagram is using these symbols, we should try and use the same ones. And that's it for this. So here we are in Excel. You'll name it. I haven't bothered here because it's just a demo. The first column is going to be the what I'm calling the ID. The idea is that we can now look at this thing and we can identify a loop or a junction by these letters. So A, B, E, F would be my first one. B, C, E, D, E would be another loop. B is one junction, E is another junction, etc., etc. This is just a way to keep track. So my ID, I'm going to just pick 4 letters. And now I have a possibility of several resistances. R1, tab, R2, tab, R3, there. That should be good. And now I also have I1, I2, I3. Oh, I forgot the voltages here, so I want to insert 2 columns right here in the front. So I highlight 2 columns by dragging across there, right click and insert. And this is going to be VA, and this is going to be VB. So to make this a little nicer, I can do this. I can highlight them. I could say at home. I can center, which I've already done here. And I can, if I'm in the cell and I press Alt-Enter, I take a new line in the cell. So here I want to put the units for what's being measured. I'll make it a little wider. You can do that with all of them. For resistances, you need ohms. You go insert and symbols, and you'll find it there. So here I'm going to put in my first loop, there's only one, so I'm just going to put arbitrary numbers here, 15. This one is not in the loop, so I leave it blank. R1, we'll say it's that first one, so we'll go, I don't know, 10. And the current at 0.4, and R2 is also in this loop. R2, we'll just call it 15. And I2, I'm going to call it 0.5. Oops, 0.5. Now, there's something you have to realize with the currents. When you label the currents, you're going to have to pick a direction. And if that direction requires it, you may have to put in a negative sign here. The worst that can happen if you pick wrong is that you'll end up with a negative sign, or it may not even matter. But just be aware that it may happen. And R3 is not in this equation that I'm doing, so there we go. So now I want the inputs, which is just for a loop, it's the input voltage from the power supplies. For a junction, it's the current flowing into the junction. And outputs, which is in this case the resistances, which are dissipating energy from the circuit, and the currents flowing out of a junction. So, but I want to calculate these. So how do I do that? Well, I tell Excel, I want to calculate this cell. I do that by pressing equals. And I want the sum of the voltages. Well, there's only one voltage here, so enter. And now the outputs, I also want to make a calculation, so I hit equals. And here I have 2, but I don't have voltages. I can't compare voltages and whatever currents and stuff like that. I have to find the voltage using Ohm's law. So I'm going to go R1 times I1, but there's 2 of them, so now I hit plus, and then I'm going to hit R2 times I2, and that's the end, so I hit enter, and I get a value. And if you've done it right, hopefully you're a lot closer than I am. Interesting would be the percent error. Actually, let's do the percent difference. We're going, because these are both measured quantities, we're going to use the average to divide by. So how do I do that? Well, I'm just going to call this percent. And I'm going to click here and I want to make a calculation. So I hit equal sign. And I want to do the difference between these 2 values. So this minus this. Now there's a problem here. That could turn out to be negative, and I don't want it to be negative. Percentages should not be negative. So I'm going to put this in a parentheses. I'm going to go back to the front and put ABS parentheses for absolute value. So now I come outside the parentheses and I want to divide by the difference between the 2. If you're not sure what I'm talking about here, you should look up percent difference. It's in the documentation for the that provided by the department, and it should be available anywhere on the internet. So now I want the sum. So and here I'm going to put parentheses immediately. So the sum is going to be this plus this, close that parentheses, and now I have to multiply by 2 because I'm taking the average down below. That's what all that stuff is. So I'm going to divide the difference by the average, and I'm going to hit enter. This gives me a fraction, not a percentage. So, but if I highlight this, drag down to cover some squares, and I go back to home, I can press percent, and it will give me a percent. And I can go here, and I can use these to increase the number of decimal places. And that's what you're doing. In each case, you'll have a number of loops, you'll have a number of junctions, and in each case you'll fill in what has to be filled in, and you'll carry through this kind of a calculation and compare it. And then in the conclusions, it tells you what you have to do with all that. And that's it. This is a simple little app. Too simple, actually. Should have had another circuit, or a more complex circuit. Look up Wheatstone Bridge. I'm going to, for my students, you know what, I'm not going to tell you that. I'll tell my students that, not everybody. This is your lab for this week. Good luck.